There is a place in the universe where even light cannot travel normally, where time slows down, space bends, and matter is crushed into something that should not exist. And if you were anywhere near it, you wouldn't just die, you would be erased by physics itself. Far beyond our solar system, thousands of light years away, hidden between glowing stars and cold clouds of dust, there exists a system so extreme that it challenges almost everything we think we understand about reality. Two objects orbiting each other at incredible speed, distorting the space around them, bending the path of light, and altering time itself. At first glance, they don't seem impressive. They're small, barely a few dozen kilometers across. But that's exactly what makes them terrifying, because they carry the mass of entire stars. To understand how something like this can exist, we have to go back to the beginning, to a time when these objects were not strange at all, but ordinary stars, massive, bright, and unstable, burning through their fuel at a rapid rate as they approached the end of their lives. Every star exists in a fragile balance between two forces: the outward pressure of nuclear fusion pushing energy into space, and the inward pull of gravity trying to collapse it. And as long as those forces remain balanced, the star survives. But when the fuel begins to run out, that balance breaks. Fusion slows, gravity takes over, and the star begins to collapse under its own weight. As the core compresses, temperatures rise to extreme levels, triggering a final burst of nuclear reactions in a desperate attempt to resist collapse. But it doesn't last, because gravity does not stop, and the star explodes, a supernova, one of the most violent events in the outer layers are thrown into space, forming expanding clouds of gas and debris, while the core is crushed inward with unimaginable force, compressing matter beyond its normal limits, breaking atoms apart, forcing electrons and protons together into neutrons. A neutron star, an object so dense that a single cubic centimeter of its material would weigh billions of tons, something so compact that an entire star's mass is squeezed into a sphere no larger than a city. Now imagine two massive stars close together, both collapsing, both exploding, and instead of drifting apart afterward, they remain bound, locked together by gravity. What forms is one of the rarest systems in the universe, a binary pulsar. Two neutron stars orbiting each other at incredible speed, circling a shared center of mass, moving so fast that they complete an orbit in just a few hours.
Each of them is spinning rapidly, generating intense magnetic fields and emitting beams of radiation into space. And as these beams sweep across Earth, we detect them as pulses. That is why they are called pulsars. One of these objects spins dozens of times per second, an entire star rotating faster than a household fan, while the other spins more slowly, but still at a speed that defies intuition. And as they orbit each other, something extraordinary happens. Space itself begins to bend. Light traveling near them no longer follows straight paths, instead curving under the influence of their gravity, creating distortions that can be measured from across the galaxy. Time is affected as well. At the point where the two stars are closest together, time slows slightly, not enough to notice directly, but enough to measure with precise instruments, an effect predicted by relativity and confirmed through observation. This is not theory. This is reality. Even the signals they emit are altered. As radiation passes near one of the stars, it loses energy, stretching into longer wavelengths, creating a redshift effect that reveals just how powerful the gravitational field is. Their orbit is not stable either. The point at which they come closest shifts continuously, far more dramatically than anything we observe in our solar system. A relativistic effect amplified to extreme levels. But beneath all of this, something even more important is happening. Every time these stars move, they lose energy, not through light, not through heat, but through gravitational waves, ripples in spacetime itself, waves that travel outward across the universe. And as that energy leaves the system, the stars move closer together, slowly but constantly, just a few millimeters each day. It seems insignificant, but over millions of years, it becomes inevitable, because eventually they will collide. And when they do, the result will be one of the most powerful events in the universe, a merger that releases an enormous burst of gravitational waves, spreading across galaxies, carrying information about the event across unimaginable distances. For a brief moment, the system may shine brighter than entire galaxies, and then it will collapse into a black hole. But even before that final moment, these objects already represent some of the most extreme conditions known. Their structure unlike anything else, a thin atmosphere only millimeters thick, a crust under constant stress where starquakes can crack the surface, forming structures that under their gravity are comparable to mountains. Beneath that crust lies matter so dense that its behavior is still not fully understood, where neutrons are packed together beyond normal limits, and deeper still, possibly something even stranger, forms of matter that exist only under these conditions, theoretical states that we cannot yet confirm. These objects are not just astronomical curiosities, they are laboratories, natural experiments in extreme physics, places where the rules we understand begin to break down. And yet, they are real. They exist, right now. Somewhere out there in the vastness of space, systems like this are quietly evolving, orbiting, losing energy, moving closer together, approaching their final moment, unseen, unheard, until the very end. Because in the universe, nothing is permanent. Not even stars, not even the most extreme objects we can imagine. Everything moves towards something else, something final. And when it happens, the universe does not stop. It simply continues, as if nothing ever existed